any waves that would be big enough to mess up your vessel. You must have not navigated right. You must have hit something out there. Well, then we started getting pictures and videos. They realized there are big waves out there. What do you call one lone giant wave? No. Rogue wave. A rogue wave is now explained as perfect constructive interference. A whole bunch of wave crests come together perfectly to form one giant wave called a rogue wave. July 3rd, 1992, Daytona Beach and Ormond Beach. An 18-foot wave suddenly came out of the ocean, swept onto the beach. 75 people were injured. 200 vehicles that were on the beach were wrecked. The water went all the way up to the back of the hotels and the condos. One single wave, no warning. Got two pictures for you. First one off of Charleston, South Carolina. We've got a tanker here. And the seas don't look too bad. You get a little bit of wave action over there, but here's this one giant wave coming right in front of the vessel here. The light didn't help too much, but anyway, this wave is obviously well above the deck. It's just going to splash all over the deck of the vessel right here. Second picture, similar to the first. Offshore, we got a couple of white caps way out here. But here's this one giant wave washing over the deck of this tanker. Unless the pilot understands what they're about to face, what's going to happen? You can sink the ship. Raise your hand if you ever saw the movie Poseidon Adventure. One of you? You people need to get out of here. They're on a cruise ship. They're looking at radar, just seeing what vessels are out there. And on the horizon, they saw this white line. They go, what is this? What is this white line out there? It was a rogue wave. By the time they reacted to it, it was too late. The rogue wave hit the vessel sideways, broadside, flipped it upside down. And the whole movie was the people, the passengers, trying to get up to the hull, because that's now on top to escape. How do you get through the hull? They went back to the propeller shaft and they got rescued back there. Sorry to wreck the movie, but that's what we're talking about. So how do you hit a rogue wave? How should you hit this? Straight on. You got to slice through it bow first, otherwise you're going to sink. The Queen Elizabeth liner hit a 100-foot wave in the North Atlantic. It so wrecked the ship they had to turn around and go back to port. A ship at sea is going to encounter 300,000 waves in a month's time. One of those 300,000 will be a mega wave. And unless they're prepared to slice through it, they're going to be wrecked if not actually sunk. So let's suppose at Daytona Beach, you're an authority, you're an official. How are you going to account for this? How would you account for big waves coming into Daytona Beach? What would cause it? What would you guess? Big wave. Well, it was not like that. Earthquake would be your first guess, getting the big wave up on top. Closest seismograph to us is Patrick Air Force Base. No, quiet. Then what would you think? A meteor or comet. Nobody saw any silver streaks coming from the sky. Even if you did, you'd never find it. You wouldn't know where to look. What makes waves? Wind. We had a bunch of thunderstorms off of Jacksonville. You know, before a thunderstorm hits, we get that surge of wind, the trees start to sway, oh, we better go inside. They could have combined their winds to produce one big wave. Bottom line, we don't know. We don't know exactly what caused the rogue waves, but they're there, we're getting pictures. So again, perfect constructive interference. Any questions? Again, keep those straight, definition and examples. So let's go to that next part on explaining why the ocean polluted. is the ocean blue and not red or green or some other color? It's gonna take a while to explain this. As I said at the outset, a little kid comes up to you, says, you're a college student, tell me why the ocean's blue. Make something up, as you're gonna see here right now. We're gonna have to take a look at what's called the electromagnetic spectrum. The electromagnetic spectrum is showing what happens when moving electric charges send out waves of energy. We're going to call those waves of energy radiation. There are different kinds of radiation, and those are shown or listed in what's called the spectrum. Moving electric charges send out waves of energy that we call radiation. So we're going to check out what we need, going from long wavelength down to short. Quick review, what's wavelength? Hello? Distance? Crest to crest. Distance between waves, how far waves are apart. We're going to start with lots of distance going down to short, and we're also going to go from low energy to high. Trying to produce a whole bunch of short waves is very high energy. Now, as kind of a crazy example, you've all seen a beauty queen up on a parade float, some kind of parade, and she's waving at the crowd like this. Long, slow waves, that hard or easy? Easy, you do it for 6 hours, your arm falls off. Now I'm going to do it short and fast. Is that hard or easy? Hard. So if you make a whole bunch of quick, short waves, it's going to be much more energy involved. All right, let's begin with long waves. First stop we need for oceanography is, back to that again. The actual reason that submarines cannot use radar, they're still using the old technology sonar, is because you've got something in your kitchen that's the same thing. What? Microwaves. Radar and microwaves are just about the exact same thing as far as wavelengths and energy goes. So if you're in a submarine trying to use radar, what's going to happen to the fish? You just fry the fish. Microwaves are absorbed by water, which means it's not getting anywhere. You try to use radar underwater, any fish out here you fry, the water absorbs the microwave. If your foodstuff has got any kind of moisture content to it at all, the water molecules pick up the microwaves and they start to agitate. They start to shake and move around. That's their definition of temperature, heat. And it gets hot. Suppose you put a bare paper plate inside the microwave. Set it for a minute or two. How's it come out? Bare paper plate. How's it come out? It's not cool. It won't heat up because there's no moisture content. If you get some moisture content, then it gets heated up. So submarines have to settle for sonar, and as we saw, it's fast enough they're not going to be surprised. So even though it's ancient technology, it still works for them. Next on the list is infrared. The word means inferior to the color red, so visible light. This is coming in next. We feel it as heat. You stand outside on a hot sunny day, your skin, your body, your clothes pick up the infrared from the sun, you feel warm as a result. Visible light is taken as neither long nor short. It's taken as being in the middle of the spectrum. Red versus blue is going to be very subtle changes in the actual wavelength of light. Question. Which one's shorter? You already wrote down the answer. Which one's shorter, red or blue? You already wrote the answer. You just did infrared. What did we start with? Long waves. So which one's short? blue. Blue is about half the wavelength as red. Which brings up two very interesting questions. Are emergency colors supposed to be red? Your tail lights on your car are red, ambulances, fire trucks are using red lights, emergency symbol, traffic light red, you better stop. But police cars are using blue. How come? Figure it out. What did we just say about the blue?